welcome back to another lecture from chapter 2. Okay, so the question that we have here, we have 3 compounds, and it says we have two hydrogens, and we want to figure which one is more acidic, the red one or the blue one. So those are the reds. Okay, let's see. I'm going to use, okay, so assume this is the red. It clearly is not red, is pink. And then the blue one, and let's trust this as a blue one. Okay, so red or the pink versus the blue one. Okay, which one is more acidic? Okay, so I'm gonna jump and work on number on B, then C, and after I'm done with C, I will switch to A because A is a bit tricky. Okay, we have 2 hydrogens. Okay, if I take this hydrogen, let's call this one A and call this one B. Okay, if we react this one with a base and take, for example, the A acid, we get this. Okay, oxygen, in order to be octet, needs 2 lone pairs, each oxygen. So I'm going to put 2 lone pairs on each oxygen. Then we have a hydrogen, and here oxygen, 2 lone pairs. Then we have a carbon, and that carbon, it has 2 hydrogens. Okay, remember we have 2 hydrogens there. Okay, I took the blue one. Okay, now I'm going to have a lone pair on this carbon. Okay, can I get a resonance structure? Okay, that carbon, okay, this carbon, say the blue one, okay, it can do resonance with this oxygen. Okay, so this is going to happen. This lone pair, it will show up here, and oxygen will take the lone pair. Okay, so that oxygen is going to take the lone pair. Okay, let me move it a bit down. Okay, oxygen will take those 2 electrons, and they will show up here as a lone pair. Okay, so we're going to get this. We're going to take this structure, sorry, paste there. Okay, we're going to get a double bond. Okay, so I'm going to raise the lone pair. That lone pair is gone. Now I will have a double bond with oxygen and also break that one. So that one is gone. Okay, this is going to be my double bond. Okay, and I'm going to show a lone pair and oxygen. Now oxygen is -1, while carbon is 0. Okay, here carbon used to be -1, while that oxygen is 0. Okay, so there is one possible resonance structure. Technically we have 2 resonance structures. If we take hydrogen, the blue hydrogen. Now what will happen if we take the red hydrogen? Okay, if we take the red hydrogen, I'm going to draw it another page. So let's say we are taking the red hydrogen. If I take the red hydrogen, or B, I get this. I get carbon attached to oxygen with 2 lone pairs. Okay, now we have a carbon. This carbon has a hydrogen. And which hydrogen? One more hydrogen there, because hydrogen and carbon are supposed to be octet. Okay, we took the red hydrogen. Now we have a lone pair. Okay, we're going to get a carbon here, and the carbon attached to oxygen with 2 lone pairs, and we have carbon here, and that carbon attached to hydrogen. Okay, is there any way to form any resonance structure, any pi bond with that carbon? Okay, that carbon, it can transfer the lone pair here or there. Okay, so it has 2 possibilities. If we go through pathway 1, okay, 1, and that's going to be 2, we will get such a thing. Okay, we will get carbon attached to oxygen. Oxygen, it will have 3 lone pairs. Now we're going to have carbon attached to another carbon through a double bond. Okay, next I have carbon attached to oxygen, and oxygen, it has 2 lone pair, and then we have carbon, and there is H there. Of course, we have 1 hydrogen here. Okay, now this oxygen, it will be -1, while carbon is 0. Okay, or you can, if you go and share the lone pair with the carbon on the right side, you might get that. You will get this technically. So double bond will be there, and now we have oxygen attached to carbon through a single bond. So oxygen will have 3 lone pairs, and then we have carbon that's attached to hydrogen. Where is the double bond? Double bond is going to be here. Of course, you have hydrogen there. Okay, so how many resonance structures I got? Okay, let's start from here. This is the first resonance structure. That's going to be the second, and this one is the third resonance structure. So I got 3 if I take the red one. If I take the blue one, I get only 2 resonance structures. Which one is more acidic? B, it will be more acidic. Okay, or the red one. Okay, it is B, more acidic. Okay, next. How about this? I can take A or I can take B. Okay. If I take A, okay, so if I remove A, I get this. I get carbon attached to oxygen. And then I have oxygen here, and oxygen is going to have 3 lone pairs. Then I have carbon, carbon. Okay. Then here, nitrogen. Okay. Methyl. This is going to be nitrogen with NH2. Remember, in order to make oxygens or or nitrogens active, we need to add lone pair here, oxygen 2 lone pair, and each oxygen again 2 lone pairs. Okay. Now, can I have do I have a negative charge on any oxygen? Yes, there is 1 negative charge there. Can I share this lone pair here and take that one and give it to oxygen? Yes, that's possible. So how about this? Okay. So if I share the lone pair, so that lone pair is gone now. Okay, and we're gonna break the double bond. We put the double bond here. That oxygen, we're gonna give it a lone pair. Okay. Now, by zoom, this oxygen, it will have 0 formal charge, and that one is -1. Okay, if you track the charges, okay, negative charge used to be down, now is on this oxygen. Okay. So used to be here, now is there. Okay, so these 2 resonance structures are identical. Honestly, the only difference is just position of the negative charge change. And okay, but right now I got 2 resonance structures. Okay, I got 2 resonance structures. And where is the negative charge? The negative charge is on oxygen atom. Now, remember this: an electronegativity of oxygen higher than electronegativity of nitrogen and higher than electronegativity of carbon. Negative, we do have negative charge, but negative charge is an oxygen. Okay, now let's go after hydrogen, and that's is sitting on nitrogen. So I'm gonna go after hydrogen that's sitting on nitrogen. So I'm gonna go after B. Okay, let's remove that hydrogen. Okay, and we're gonna get this. We're gonna get oxygen attached to carbon. Okay, and oxygen has double bond there, 2 lone pair. This oxygen has 2 lone pair and 1 hydrogen. Here we have carbon, carbon, okay, carbon. Then down here we have nitrogen, the lone pair, and methyl. Okay, what do we have on the other side? Okay, this nitrogen, it has a lone pair, just 1 lone pair. If you remove 1 H from it, you will have 1 H, and also you get a lone pair. Remember, we treated with a base, so we're going to get HB. Okay, of course, I did the same thing with others. So always, all this, we treated them with a base, and we got, like a HB. I can go back here again, same thing here. I treated them with a base, and I got HB. And how about this? Again, it's already written. We treated them with a base. Okay, so we have to use a base to take the hydrogen. Okay, now, what's the formal charge for this nitrogen? Let's calculate the formal charge. If I draw a circle around it, it will be, okay, nitrogen is a group 5. I see 7 electrons around it. Okay, 6 electrons around it. Okay, yes, 6 electrons, so it's -1. Okay, -1. And okay, so this one will be +1. Okay, -1 by +1, it will be neutral, and everything it will be fine. Now, can I get a resonance structure? Yeah, it's possible to get 1 resonance structure. How can I get that resonance structure? Okay, let's do this. Let's share one of this lone pair one of these lone pair, we share it here. And then we take those 2 electrons and we give them to nitrogen. So what we're going to do, we're going to take this lone pair and we will put it here. And those 2 electrons, we're going to take them and give them to nitrogen. Okay. So if we do that, that lone pair, it will be gone. And I'm going to show it as a double bond. Okay, I got a double bond. Now, what do I need to do? This double bond, it will be gone. And I'm going to get a new lone pair on nitrogen. Okay, the top nitrogen is a group 5. And I see 1, 2, 3, 4, 5 electrons around it. So it will be 0. How about the bottom one? The bottom one, if you calculate the formal charge for it, okay, nitrogen is a group 5, but I see 6 electrons around it. It will be -1. Okay, so check this. This one used to be 0. Okay, the top one -1. Now we switch their position. The top is 0 and the bottom one is -1. Okay, where is the negative charge? Negative charge is on nitrogen. Okay, how many resonance structures do we have? We have 2 resonance structures. So let's compare it with the previous one. Previous one had 2 resonance structures. If you take hydrogen that's sitting on oxygen, where is the negative charge? On oxygen. The second one, if we take hydrogen from nitrogen, you get 2 resonance structures. Where is the negative charge? On nitrogen. Okay, so number of resonance structures are the same. Now we have to look to the electronegativity. We said the one that has higher electronegativity, it will make it more stable. So electronegativity of the atom, okay, ARIO. Electronegativity is the one that's dominant here. Okay, so the top one, it will be more acidic. Okay, or like the the red hydrogen, it will be more acidic. So I'm going to say A, which is red hydrogen. Red hydrogen is more acidic. Cool. I'm going to stop here, and I will see you very soon with another example. And this is going to be the A. It's a bit complicated. Okay. Thank you very much.